Prasasthy is a PhD researcher at the Center of Ubiquitous Computing, University of Oulu, Finland. She received her master's degree in data science from Liverpool John Moores University. Her current research interests include cyber threat intelligence, deep learning, conversational AI, explainable AI, and generative AI. Her workshop is entitled Building Your Own AI Chatbot with GPT. During this workshop, you will also gain experience, hands-on experience to be specific in AI chatbot development using the powerful GPT and more. She will take questions throughout her talk. Please submit your questions in the Q&A or the chat, and the code and the links will be shared after the talk. Please welcome Prasasthy.
Thank you, Magnona. I hope I'm audible to everyone.
Yes.
Okay. Hello, everyone. Good morning, good afternoon, good evening. Not sure which part of the world you are attending this. I am joining from Oulu, Finland, the happiest country in the world. For me, it's 8 p.m., so it's good evening for me. As Magnona mentioned, I am a doctoral researcher from UBCOM University of Oulu. A little bit on our team, we have different research fields we are working on, like cybersecurity informatics, perception engineering, interactive edge computing, crowdsourcing, etc. We are also working on a wide variety of technical stacks that include different aspects of artificial intelligence and machine learning, augmented reality, virtual reality, mixed reality. So if you are interested knowing our research work and other details, you can go to our webpage. Amy would be sharing it in the chat. Speaking on today's workshop, building the conversational agent with GPT. So I basically want to take it in different segments. The first segment would be just theoretical information on the conversational agent, development of GPT models throughout the years, and a little bit on the stack, technical stack that we are going to work through the workshop today. Then I'll demonstrate some of the implementations of our team, like the chatbots, which uses the same stack that we are going to use in the workshop. So it will be helpful for you to understand how the final model would look like. We have already published scientific papers regarding these implementations. I'll share the link. You can have it as reference for better understanding. And then I'll take the coding session. Coding session, as Magnona mentioned, there's a GitHub link. Amy would be sharing in the chat again. You guys can go there, download the code. So it will be in two steps. One will be the basic bot framework. It basically a general bot framework. It's pretty easy to implement. And the second would be a customized bot framework specific to the domain. As my interest is cybersecurity, today I'm going to showcase a cybersecurity agent capable of identifying spam text data. And I've already trained one of the large language model BERT for this functionality. So I'll showcase how this different large language model is integrated with GPT 3.5 Turbo for the chatbot interaction. Both the frameworks will be developed in Jupyter Notebook. You guys can use the Google Colab, which is freely available for the implementation of the code. And in the next segment, I'll be explaining a little more on the ethical consideration. These things need to be considered while developing a chatbot, which is really crucial nowadays. And finally, we can take the Q&A session on this. So let me share my screen. Just give me a second. Hope this is visible to everyone. So as I mentioned, I'll be starting with the information on the significance of conversational agents. Before that, I would like to give a preview on the history of how the conversational agents have been developed. Basically, it started in 1960s and 1990s. If you have been part of previous with sessions, there was a session on conversational agent, I remember. So I will not be elaborating it, just briefing on this. So ELIZA was the first and foremost conversational agent that was developed. And the technique behind ELIZA was pattern matching technique. After that, in 90s and 2000s, we had the rule-based systems, which is a combination of user-defined rules and pattern matching technique. Then with the advancement in the natural language process in 2000, there were many conversation agents that was developed and used, like IBM Watson, Apple Siri, and these products had a little bit of AI integrated to it. With the emergence of the AI chatbots after 2010s, there were, I would say, extensive development in the conversational area, and we had Facebook M, Google Assistant, Microsoft Cortana, OpenAI also released GPT-3 model with the ChatGPT, the most significant one. Then Google released Bard model. All these are, there are many lot. I wouldn't be able to list down everything, but some of them are these. Then if you see the slide, you can find how significant it is. Like it provides a 24/7 support, which is really true because human agents cannot provide that. It's a very cost efficient compared to human agent. Personalization is possible. Data insights are available. Scalability is possible. Multilingual support is possible. Consistency, accessibility, and it is deployable to many domains like customer service, healthcare, education, marketing, etc. It improves the human machine interaction also. And with this, like the future of the conversational agents, it's brighter with the advancements of AI, which is rapidly progressing. And some of the future we are looking forward is like context aware, emotionally intelligent, and capable of holding more natural and coherent conversations. It's also like it can make more personalized, sophisticated applications with more multilingual capabilities, and can be integrated with other advanced technologies like augmented reality and virtual reality. So these are some things that we are looking forward about the conversational agents. Then going to the GPT models, which is basically the highlight of the workshop, today's workshop. So as GPT models are based on the transformer-based architecture. Transformer basically have an encoder and decoder architecture. In June 2017, there was a paper that was released, Attention is All Needed, which explained about the transformer architecture and more detailed information on the self-attention mechanism of it. In 2018, Google released BERT model. BERT is bidirectional encoder representation for these transformer models. And in the same year, OpenAI also released GPT model, GPT-1 model, Generative Pre-trained Transformers. BERT was basically encoder-focused architecture, and it used masked language modeling technique, and it used for predicting the missing word based on the context of the previous and the next word. BERT was used for the tasks like text classification, entity recognition, and question answering tasks. And GPT model is based on the decoder architecture. It uses autoregressive language modeling technique. It's basically used for next word prediction based on the context of the previous tokens or the previous sequence of tokens. It is used for tasks like text generation, text completion, speech recognition, machine translation, etc. If you dwell a little more into it, you can understand that these models basically try to grasp the context of a single token, previous single token, or a sequence of tokens, or it's like a word, phrase, or sentence. And it uses probability distribution to predict the likelihood of each possible token that could come next. The model samples its probability distribution to select the next token. Selection is often stochastic. It means it's strictly non-deterministic, which creates actually some degree of randomness in the generated text. So that's why basically, if you use the same prompt twice to say to the generative model, it produces a response in the sense two different responses can be produced. So the logic is basically this, that it uses stochastic, not strictly deterministic logic. And once a token is generated, this token becomes a part of the input sequence context, and it is used for generating the next token. So it's kind of a cycle that goes on, repeated multiple times. until and unless a certain length is reached, or it's kind of like a specified number of words are requested by the user. It basically look for that, like end of sentence token is produced or not. So that's that, a basic on the GPT models. Other than GPT and BERT, there are other language models like XLNet, Roberta, Albert, T5. So with the development of GPT model, if you see in 2018, as I already mentioned, GPT-1 was developed with 117 million parameters, and it was trained on approximately 8 million web pages. In 2019, GPT-2 was developed, and it was having 1.5 billion parameters, approximately 40 GB of text. 2020, GPT-3 was released with 175 billion parameters. They used 570 GB of text. 2021, OpenAI Codex was released. This is basically a code generative model, and I'll not be going in detail of that. In 2022, ChatGPT was released. So ChatGPT was built based on GPT 3.5. To understand GPT 3.5, we need to understand what is GPT 3 basically, because it's a fine-tuned version of GPT 3 model. So as I already mentioned, GPT-3 model has 175 billion parameters, and it was trained on 570 GB of textual data. It basically follows the decoder-focused architecture as any other GPT models, and it has 96 attention blocks with 96 attention heads for each block. It uses auto-regressive language modeling technique for next word prediction. It takes input sequence of length 2048 words. Even if you are inputting a shorter sentence, what it basically does is it replaces the empty values to extra spaces, and it also output a sequence of 2048 words. Though it gives an output of 2048 words, basically the last word of the sequence is considered as the response generated. And for the encoding part, GPT model has a vocab size of 50,257 words. But when an out of vocab word is encountered, it uses byte pair encoding subword tokenization method, which uses positional encoding to generate the tokens for these out of vocab words. So that's the tokenization method that is used. Once tokenization is done, next go to the attention mechanism. GPT model, GPT-3 uses multi-head attention mechanism basically. So these tokens are used for calculating key query value vector information, and it uses dot product multiplication to create the score matrix. Since it is using a dot product dot product multiplication, possibility of explosion is there. So in order to regulate this, it is scaling it by dividing the dimensions of query and key. A softmax layer is then used for generating the probabilities of these tokens, which varies between 0 and 1. So this basically helps the model to understand which token need to be given the attention, or like which token need to be considered while it's predicting the next token or the response generated. So that's how the attention mechanism helps the model to understand the significance of these tokens. Once the next token is generated, it is added to the previous sequence of input, and for the further generation of next token. So as similar to any other GPT model, the cycle is repeated unless end of sentence token is produced. So as I already mentioned, GPT 3.5 is the fine-tuned version of GPT-3 model. For fine-tuning part, OpenAI use customized supervised dataset. For creating the supervised dataset, they took the help of a bunch of AI labelers. What they have done is like they have used the user-defined prompts to the GPT-3 model, and the response generated by the GPT-3 model was further customized to create the desired output. So the entire dataset was customized according to the AI labelers responses and manually modified responses. And this customized dataset is used for fine-tuning the GPT-3 model, and the final fine-tuned GPT 3.5 model was developed. ChatGPT is basically based on GPT 3.5 model. It uses 3 different techniques at the backend. One is the raw supervised fine-tuned model GPT 3.5. Another is based on the Instruct GPT. Instruct GPT is one of the model that was released before ChatGPT. It was released in 2021. It was based on an existing technique called reinforcement learning from human feedback. Basically, it uses the GPT-3 model to generate multiple responses for the prompts provided by the customers. Then they are manually ranked based on relevance identified by the AI labelers. So here there is no customization is happening. It's basically they are ranking it. This ranked data is then used for fine-tuning the GPT-3 model to create the Instruct GPT. So the same logic is used behind the Chat GPT, and it creates a reward model. Basically, they are using another technique called proximal policy optimization reinforcement learning technique, where they are again using the fine-tuned GPT 3.5 model to create the responses for the same prompts that was passed through reward model. So with the responses generated by the PPO optimization RL technique model is evaluated based on the reward model, and some output rewards are given if the quality of the response is good. And these rewards are used for fine-tuning the parameters of the final GPT 3.5 model. So that's how the Chat GPT technique, it uses these, it becomes a superior to Instruct GPT and GPT 3.5, along with the proximal policy optimization reinforcement learning techniques. The next, I believe in the same year and month, GPT-4 was developed, but I'll not be going in deep of that. And in September 2023, voice and image capabilities were integrated to ChatGPT. It's still in use, actually. So that's brief on that. This is the basic architecture of Transformer and GPT. Transformers do have the encoding and decoding part. GPT is focused on the decoder side. Next, I would like to give some information on the stack requirement. Basically, in data science, we often collect data, clean the data, and we train the model. We also create the predict module. We always find difficulty to showcase to the customer, where the challenge is you need a user interface. So because the user interface always have a different stack of technology that need to be used. And it is always challenging for a data scientist who is specialized in Python to get himself or herself trained in that. As an alternative, there are Python UI simulators available like Tincture and Streamlit, and Gradio. Gradio was offered by Hugging Face, which is very efficient compared to Tincture and Streamlit. I have extensively used Streamlit and Tincture and Gradio as well. I could find that Gradio is much faster and easy to implement. It can be installed pretty easy, and moreover, creating interfaces with Gradio requires only very minimal number of codes. Unlike other packages, Gradio can be run on a Jupyter notebook as well. That's what we are going to see in our workshop, in the sense coding session. We are going to use a Colab or a Jupyter notebook to implement Gradio user interface here. Gradio creates a shareable link, which are probably the fastest way to get deploy the machine learning model. This is one of the highlight of the Gradio. It helps to avoid the MLOps. MLOps is another challenge as similar to that of user interface. So Gradio helps to avoid these challenges like user interface and MLOps here to deploy the machine learning model faster. Gradio has a well documentation, and it can be used for integrating multiple models. This feature we are going to utilize for generating this chatbot as well, because we are going to integrate BERT model as well as GPT 3.5 model in the same chatbot, and we can see how it can be done. Now, the next segment, I'll share some of the demonstrations. Just give me a second. So I hope you guys are able to see it. This is Cygen. This is one of the application we developed. We have the functionality called summarizing and anomaly detection. These are all cybersecurity agent actually. So one of the functionalities is that you can upload the document to it. You can see the response is generated over here with a very limited, speed and all. This is controlled based on the logic. So it helps to create the summarization of the log file. We have also the file history where the file informations are stored, and you can use the existing data from get the existing data from it from the database if you are connected to the database. Then this is one of the dashboard. Basically, this entire dashboard was developed in Gradio. Here you could see we were able to integrate the chatbot here along with the dashboard. You can chat with the chatbot based on the content in the dashboard. This contains explainable AI also. So basically, we select the threat detection data points over here, and you can chat with the chatbot regarding that. You can generate the reports as well. So there are multiple algorithms and applications running behind it. So Gradio helps to integrate everything at a stretch. That's what I would like to showcase over here. Then next section would be like the coding section. I have created like this Jupyter notebook. You can see there is a architecture I have integrated here. This is a basic architecture. You could see how the chatbot interface and the backend OpenAI is integrated, and how it's interacting with each other to provide a response to the user agent. If you have the Google Colab, you can start coding. I can showcase, just give me a second. The basic installation required is the Gradio and OpenAI. So here you can see that some packages are imported over here. You're using the OpenAI key over here. Then you declare the message. Message is basically different roles and the content of the roles. It can be like system, user, and the assistant. And the content explains what the response required for each role. There are some like functionalities defined over here, but it's basically on pure Python. You can see here we are declaring the Gradio block. The Gradio block is basically the user interface declaration, and it is declared as demo here. It can be launched here. Various components can be declared. You can see the chatbot component is declared here. I put a label also here. This is customizable. And there is a text box where the input from the user is taken. You will be able to see here. This is the text box that takes the input from the user. Currently, it is not running, so I won't be able to run this. But we will be running it in the Google Colab. And once the user submits the data, it captures the data and passes to the user. User is a function which we have defined here. It basically takes chatbot and the text as the input. Basically, the chatbot history, what were the chatting happening between the AI assistant and the user. So, and the text will be like the current input from the user. It will be passed to the user defined function. Here, it will be added to the history. I have put a print on the history to understand how the structure would look like. If you could see here, the first was like, there was no response on that, and the history looks like this. It's basically key value pair over here. Once it is done, the response is captured again, chatbot and text here. And following that, it calls another function called bot, and along with the history information. So here, if you go, the history information is captured here. And the query that was asked is captured here and sent to the GPT model. Before sending to the GPT model, we set the role and the content, how content would be like the user input, and the role would be like user, and the response is captured here. The response received will be in a JSON format, in a nested JSON format, and you could see the sample nested JSON format is here. So from here, basically, it captures the index 0 choices out of choices. You can see like it goes to the response, then choice, then from that 0 index is captured. Then it goes for the message information. From the message information, the content is extracted. Content is basically the response from GPT 3.5 model. This is captured and transferred to the response of the UI. You can see here how it is displayed. For more understanding, the second step is like the second query is asked. So the history is saved here as another key value pair. And in a similar way, we capture the response from the chatbot here and displayed. So for this implementation side, you can just run, once the packages are installed, you can just run it here. So you would need a OpenAI key, which you can get from the platform. I'll be declaring the message over here. One of the best thing when you're running in Google Colab is that there will not require a port, but when you're running in your virtual machine, you would need a port over there. Usually it runs on 7860. You could see that. So there is a link that is provided, and also it is already available in your Jupyter notebook. How, I mean, you could see that you can start chatting immediately and test your bot here. And if you want to deploy it in your platform, you can use this link. Also, make it as a shared to link that will also help it. So this is the basic board framework implementation. The next step is to customize it, because this basically just get the response from the GPT 3.5 Turbo. You can see here, it's not customizing anything or any other functionalities is not integrated. But it is really good to understand the basic board framework first before going to the domain specific customized board. So this basically explains the customized board. You want to run it in the Google Colab. Again, you have to install all these packages. So here, I have modified the code specific to the domain. You could see that. I have trained a model based for the spam detection. So I have trained a BERT model over here. On request, I can provide the training code as well. This is basically on the TensorFlow framework. I have not shared this model in the GitHub link. So I've declared here, if you see, the declared the message as like system, and the content is basically predefined. I have mentioned that you are going to be an AI powered cybersecurity agent, and it is named as spam detect agent. The primary goal of this chatbot would be providing cybersecurity information to the user. The task is like spam detection from the text. It should instruct the users to put the text that need to be detected in double quotes. So this instruction I provided, you can see that how the bot is going to respond when the user is asking. This is basically loading the model, which I have trained it for the spam detection. And for the Google Colab, basically I need to bound the Google Colab drive. I already have the model in the Google Colab. I've also added two different functionalities. One is to scan the message, basically pre-processing the message before passing to the model. This is the text classification model to detect whether it's a spam or non-spam. So the pre-processing part is done over here, and only the sentences that need to be classified is passed to the predict model for the bot module, which is another function we have declared here. The response is captured here. And only difference from the basic bot is like when the response is captured here, uh, it is checking whether it's a response from the model or the bot. Bot is basically still running on the GPT 3.5 here. You could see that. So if the response is there, then it will be providing the response like this, like whether it's a spam or not. And I also included a logic to make the responses really slow. This makes it more natural compared to the abrupt response. It uses the same Gradio blocks over here, which not much of differences. Could see that. Okay, maybe I'll have to declare it separately. Oh. So the chatbot is up and running. Um, I'm going to add label over here. Yes, we have created it. It's the mice chatbot. So you could see that his name is replaced as spam detect agent. probably. Okay. Mm. Often happens when you want to showcase something, code stop running. Let me restart the kernel. Or yeah, probably I'll try to run in my virtual environment. Right. Okay. No, still not logged. Okay, I think this is launched. Can see that the chatbot is able to identify himself or herself, like saying that I'm a spam detect agent. And basically, what are the informations we have provided in the message content is reflected over here by the chatbot. You can try giving some text for spam detection to make sure the model is working. Okay, cool. Let me try this non-spam. You could see that the model is working and how both the models are integrated. You could see we are using this for this BERT model for spam detection, and for the chatbot response, it basically responded by the GPT 3.5 Turbo. So here the Gradio helps to integrate both the models, and for the functionality specific, it is using the BERT model alone. So let me know if you're facing any difficulties while implementing this. I would be happy to help you guys on that, because you could see that it's a very simple implementation, and I have done it in a Jupyter notebook. And for the customized model part, if you want the training code, I can provide that. But I mean, this is a model that I trained based on the customized data, which is specific to cybersecurity. But you can do something like text classification for sentiment analysis and all. You can ask the bot to analyze the sentiment of a particular sentence. It will be the same. Instead of using the training data would be different. Just you can use this BERT model itself just to analyze the sentiments out of it. Till the same logic and the same code, you can reuse it. That's that. Then moving on to the next segment, basically the ethical consideration. So, just a second. Basically, for the ethical consideration, there are a couple of things, not couple, a list of things I have already quoted here. This is not a comprehensive list. There are many lot other things that need to be considered while creating a chatbot, and some of the basic things include these, like the privacy and data protection, and it should also give a proper identification of what that you are interacting with a conversational agent. It's not like you're interacting with a human, and also disclose the bot's capabilities and limitations. There should not be any misleading. Um, Privacy, regarding the privacy and data protection, basically the bot can collect the information and store in the database. This also need to be restricted, and this should be conveyed to the user that their data is saved and reused for certain purpose, and the consent need to be taken care. Bias and fairness of this is also need to be taken care, like eliminate the bias when the chatbot responses to ensure fair and equal treatment for all kinds of users. Regularly review and audit chatbot's data and algorithm for bias, if there is any bias or not. And user consent and control need to be like basically the user have the right to take the control out of the chatbot, in the sense the user can say that I don't want to use a chatbot, I want to go for a human agent, and whatever the information provided for the chatbot need to be removed from the database. That kind of control need to be given, and there should be accountability, like clearly define the roles and responsibilities of the development team, establish a protocol for addressing the complaints and issues, and based on these complaints and issues, different modifications can be made for the chatbot. User well-being, like ensure the chatbot provides reliable and accurate information, implement content moderation for sensitive topics, provide resources and helplines for users distress, avoid harm, basically prevent the chatbot from engaging harmful and other discussions, robust content filtering to avoid promoting hate speech, violence, or discrimination, monitor for any harmful or inappropriate content generated by the chatbot, continuous improvement. This basically is like from the user feedback, as well as the advancement of AI or like ethical themes. It need to be revisited and modified or changed based on the continuous feedback system. And the cultural sensitivity, adapt the chatbot's responses and behavior to respect the cultural norms and sensitivities, consult experts or users for various cultural backgrounds to ensure the appropriateness. So these are some of the basic that need to be taken care. As I already mentioned, this is not a comprehensive list, and ethical consideration is really crucial while you create a chatbot, because you can see that how easy to create a chatbot even using a Jupyter notebook. So this kind of ethical consideration we need to take care. And when you are deploying, and one more point which I want to discuss is how to deploy this platform, this chatbot on a platform, basically. So if you are using Gradio, I have already showed you the Hunt GPT. Hunt GPT is basically having a chatbot integrated to the platform with multiple components at the backend. We are also even using Kafka and Elasticsearch at the backend. So it was pretty easy to do that. Gradio helps that kind of flexibility. You can use a messaging queue also. Kafka is basically a messaging queue. So these are the like advantages of using Gradio and other functionalities. So some of the informations are like this. I think most of the segments I've discussed. If there are any questions, I'm ready to take. Yeah.
Prasasthy, thank you so much for this wonderful presentation. We learned a lot, and thank you for giving us a hands-on demo and how quickly and easily we can actually work on creating a chatbot just using a Jupyter notebook. I think that was a really insightful demo for everyone attending today. I have a few questions to start with. I know you worked with the cybersecurity data. You custom trained your model. My first question would be, how do you deal with hallucinations? This has been a question in the field. Everyone is concerned about how a conversational agent mostly hallucinates, and this has been an alarming concern. So how would you recommend dealing with hallucinations when it comes to this conversational agent?
Hallucination can you be more specific? Like what kind of hallucinations are you looking for? I mean, what kind of scenario are you referring to?
Yeah, absolutely. So, given a question, when there is flexibility for a creative answer in the models, it actually goes on building answers which are not within the scope. It also
Yes,
gives more creative answers to it. So, if someone who's new and who's conversing with an agent, there's a concern that the moment the agent hallucinates, you don't know where to draw a line between the ground truth
yes.
versus, it becoming real, more creative. So, how do you work with situations like that?
So that is why basically I included the segment called ethical consideration. It's very crucial nowadays because you see that how easy to deploy a chatbot, and it's not that technically difficult to nowadays to deploy a chatbot. And
Right.
possibility is that people misuse it without concerns of like ethical consideration. So if you focus on the ethical consideration, revisit these norms and rules, and make sure your chatbot is following it, these kind of scenarios can be avoided.
Got it. Yeah, thank you. I see there are a few questions in the chat. So let me start with the first one. Victoria says, "Could you give us a little more insight as to where the data is stored after it is inputted from the user?"
You mean the Jupyter notebook you are asking? So it is basically you could see. Let me share the screen again. Just give me a second. So this you can see uh, we are not saving the data anywhere over here. It's basically the current, what you say, current window or where you're using the chatbot is having this information. That's why I printed this history information over here. You can see the history, how it is getting mounted up with your questions. The first history is like hi, the first question from the user, and the responses here. And when the next question is coming, this is a list of key value pairs. It is getting aggregated. So currently, this chatbot this framework is not using any database, but you can incorporate it with MongoDB, which is a very simple integration. And if you remember, I showed you a SciGen over here
Mhm.
um, as a demonstration. This is SciGen. No, not so for the size and we are using basically the MongoDB. It is very easy to integrate this MongoDB to it. You can make these conversations saved in that database, and you can bring the like you can use JSON Web Token method to introduce login based chatbot as well. So this basically helps. These are different components that you can use to make your chatbot more specific to the user specific or like session specific, I would say.
Okay. And you can decide where you want to store it. That makes
Yes,
total.
yes. You can either use the MongoDB, that's the easiest one and free to use. You can use SQL. It basically depends on what is your choice and how much data you are going to save it.
Got it.
And I also showed the Hunt GPT over here. If you see, this dashboard is having Elasticsearch at the backend, which uses indexing of data. And we are getting data from the Elasticsearch here. But the conversation is not yet, we are not saving the conversation yet because it's like for the current data, we are using it, current session data. Yeah.
That makes sense. Uh, all right. I see another question in the chat. It says, "How would you handle mimicking more natural human talks that turns with chatbots?"
So you have learned about these large language models. It's basically the context awareness that is created. If you see, I mean, I would like to start with the basic English language. You see, you can use the same word in two different formats, like trunk of a tree or bank of a river. Like trunk of a tree and elephant's trunk, both are having the same spelling or same representation. But when you make it a context awareness, like as a human, we know that elephant's trunk is not same as a trunk of a tree. So we need to teach the model. These large language models have the capability. If you remember, I was explaining how BERT understand the context from the previous tokens, like previous words, and the next tokens, the next words. So when you're passing this sentence to BERT, basically it tries to understand trunk of a tree. This is the trunk of a tree. So it basically takes the context from this, and trunk of a tree is also a context, and it understands that this trunk is basically referring to the tree's trunk, not elephant's trunk. And when it comes to elephant's trunk, it tries to understand the rest of the words around it and understand the context, how it is represented. It creates two different representations for the same word based on the context. So once the context is understood, it's pretty easy. It's like human beings brain. It can respond accordingly, as this is the context that you are talking to us, and so it can be responded like this. So if you notice, I was explaining about the history, how the conversational agents was evolving, and Elisa was like, the first one was like pattern matching. It was not using the context, and then it was like rule based, more like user defined rules, and a combination of some pattern matches. It was able to mimic the conversations that human beings have, but it was not as efficient as it is. But when you come to ChatGPT, as I told you, it is using a large language model as well as reinforcement learning technique, which is like a very, in the sense, very advanced technique, along with the context awareness of the large language model, which helps to keep the conversation as a human interacting with the conversational agent, you know. And one of the advancement I would really like to look forward for the conversational agents is like a follow-up question. You know, this one I actually looking forward. Hopefully, it is going to happen. Like today, I'm asking the conversational agent regarding a recipe or a fix for a bug. The next day morning, I'm logging in. I want the conversational agent to ask me, what about the suggestion I made for you yesterday on your recipe or your code fix or something? Did it work? Did it help you? It's more like personalized, you know. And it's kind of like a very advanced situation when you consider a conversational agent.
Absolutely. That'll actually be wonderful if it can remember what it suggested and come back and take that as a feedback loop and improve the bond
Yes.
itself. Absolutely. That'll be a very advanced and a very intelligent state. So
Yes.
that's a great point. All right. I see another question in the chat that says, on the ethics, I've seen complaints about bias with ChatGPT discussing Palestine and Israel. What would
Yeah.
be a good way to address this?
Basically, as if you check that slide, I have already shared the slide in the GitHub. I have mentioned that these kind of basically based on the region, culture, religion, all these kinds of things, you need to restrict your customized board to respond all these kinds of information. If you see some standard boards automatically respond saying that this subject is out of my scope, please ask me specific to my domain. It would be easy for me to respond to that. So these kind of ethical conservation that need to be brought, and that need to be aware by the developers, that they need to implement along with the board.
Absolutely. And it needs to keep evolving. I would also like to add that we can't just define guidelines right now and just leave it forever. We need to keep adding to it and evolving, saying that okay, this needs to be accepted and this cannot be acceptable. These questions should not be answered. That's a
It's
great point.
actually not only the conversational agents. If you see, the AI itself is having this challenge of misutilizing. And there are a lot of forums and a lot of places where this is discussed and still discussed, and forming forums and many, many norms and conditions that AI developers should follow or like implement when they are developing the applications.
Absolutely. That's a great point there. All right, I have one more question here. I just want to be respectful towards the time. We have 4 more minutes, so let me take this question. How would you compare the QA and summarization performance of GPT 3.5 and GPT 4?
Actually, I didn't get a chance to compare with GPT-4, but I'm definitely sure GPT-4 will be performing better, because it do have a better parameters, and it is trained on better data. So definitely it's a progress that OpenAI have made from GPT 3.5 to GPT-4. Definitely it will be better performing.
Absolutely. All right. I have one last question here, and then we can move on to the next piece. Right, it says since LLMs are vulnerable to abuse, they can be used
Yes,
to create harmful content, phishing,
yes.
malware, etc. So, how do you mitigate that?
Mitigate that in the sense it's always like you cannot control these things basically, but one of the interesting thing that OpenAI have done, and they claim that it helped them to create more safer and reliable model. So this technique, it's a very known and existing technique called reinforcement learning from human feedback. So
Mhm.
I was explaining it in the session also how the instruct GPT was constructed. Basically, they use a model response which was giving like vulnerable responses as well, and they asked a AI labeler to identify this vulnerable response and rank based on the relevance of the response, because the model was creating multiple responses, and this rank data is passed back to the model for fine tuning purpose. And the fine-tuned model basically give a better response, like avoids these kind of vulnerabilities, and making the human in loop technique that help them to create more safer and reliable model. And they claim that they are going to do the same thing in going forward, and I believe ChatGPT is also using the same logic over here. So I think definitely we need to monitor. It's not like all AI, it will be definitely monitoring from the human side is also required, and these kind of logics and methods are evolving with the
Yeah, absolutely.
advancement of technology. Yeah.
Yeah, I think the advanced stage is when the human feedback is directly incorporated and it keeps going in loops so that you can quickly develop that and you do not need to wait till you're forced to, update the model or the training data set. So, absolutely, that's actually a great point you put forward there. So, I don't see any more questions, and I know we have 2 minutes left. So, thank you again so much, Prasasthy. This was a wonderful presentation, and thank you for sharing all those um, I would say cautions that you threw at the crowd, saying that when you're developing, you need to be mindful of so many things. It's not just a simple downloading of the data set and quickly using a chatbot to interact with it, but there's so many things that go into it when you want to be ethical, when you want to not introduce bias towards it, and when you want to use it for at a corporate level. So thank you so much for shedding light on these items.
Thank you. Thank you so much. Thanks, everyone. Yeah.